everybody, welcome. Today we're going to talk about how to make a good graph, and we're going to go through this process by analyzing a graph that's really poorly done. I find that although kids by this point in your career, you can look at a graph and you can say, oh, this is not well done, but you have trouble applying that to your own graph. So what we're going to do today is we're going to look at a really bad graph, and I'm going to have you pause the video and you're going to write down at least 8 things that you see that were not done correctly and what you would do to fix it. And then we will unpause the video and we'll talk about the things that you notice that were incorrect. What my goal would be is that after you've done this exercise, you will be better at identifying when you make a graph, oh, let me think of that exercise. What are some things that are not well done on this graph, and what could I do differently? So let's go ahead and look at this graph. The story in this graph is that you're looking at how much fertilizer impacts how many pounds of tomatoes a plant can produce. So we had different seedlings of tomatoes. We put different amounts of fertilizer on them, and we wanted to see how that affects the number of pounds of tomatoes that were produced. So this is the graph that was generated. So you should be able to pause the video now and look for 8 things that are not done well. Welcome back. So some things that you should have noticed. First of all, we never title a graph. The title in a science class is always going to be very long for a data table or a graph, and it should describe what the graph is about. A formula that you could use for writing titles is the effect of blank on blank. So in this case, the effect of the amount of fertilizer on pounds of tomatoes produced. It's going to be a long phrase, and that's okay. The title should be long. Don't title it tomato plants or tomato graph. It needs to be a long description. Okay. Other things that are missing is there is no label whatsoever over here. I told you in the introduction that this was pounds of tomatoes, but really you had no way of knowing that unless I said it out loud. Something else is the amount of fertilizer. We don't know. They didn't put any units. Usually we put in parentheses. Are we talking about grams? Are we talking about pounds? Talking about milliliters? What is the unit used here to measure the amount of fertilizer? Another mistake is just how small this is. You should make a graph to fit the paper given to you. So they should have scaled this differently to make it fill up the entire space. Another mistake is if you look on the side here, they go 1, 2, 4. So we were going up by 1s, and now all of a sudden we're going up by 2s. And then, now we're going up by 1 again. So you should have even increments on your scale. You should go up by a consistent amount each time. They made a similar mistake on this axis here. In addition to, what the heck is going on with this bar? Is this at 5 grams of fertilizer, or is it at some other number? If you're making a bar graph, the number should be centered underneath the bar, not to the side. It's almost like this person started to make a line graph because of where they placed their numbers, and then midstream switched to making a bar graph. Another mistake is just how sloppy it is. What is this? Is this saying 1 gram or 1.5 gram? It's just way too sloppy. You can't interpret what it says. So here's a list of the things that a good graph should have. should have a title that's descriptive. You should label the axes with units. You need to have an appropriate scale that takes up the paper. You need to go up by consistent increments. If needed, you need a legend. You can make a legend. And then finally, you have to have the variables on the correct axis. Now that was something that was done correctly on the example. Here is a memory tool to help you remember how to make a good graph. I is for independent variable, always on the x-axis, while the dependent variable is always on the y-axis. M is for manipulated and R is for responding. So the manipulated or independent variable is always found on the x-axis, while the dependent or responding variable is always found on the y-axis. Here's one last graphic that summarizes everything that we talked about. Good luck and happy graphing.